Hi, I am back. And what we got here, the mystery black box. So, this is a locker, RFID locker. Using RFID card or tag to open lock hook, usually install for drawer cabinet or small door, something like that. This device also can operate by Bluetooth wireless and synchronize with apps mobile phone. Well, what kind I'm trying to figure out it is I want to know what chip is used in this device because I guess maybe I can find some open source microcontroller like USB or STM low power or Nordic chip, hopefully. uh, Something surprising me because this device only have two cell AA battery and from company their claim this can last for 36 day 365 day, which is at least 1 year. Can you imagine two cell battery double A still live in 1 year? Other than that, this device also have a mechanic system like motor servo or DC or something, and that all make me interesting to find out what kind electronic system and secret component inside can provide power requirement and one time running in low power system. So don't further ado, let's check it. Okay, we just opened the case and you see that we find a couple of chips, but unfortunately we didn't find what we want, like some familiar microchip as we talked before. But this is also still interest. One of them is kind of chips from Sky Relay, as we see in the label, that used for reading RFID, also NFC frequency card, I guess. And another one is HS6621CG. Of course, this is only one main chips, as a controller, also as a provide Bluetooth frequency and processing data, also saving data ID card and handling output buzzer and actuator. As you see, by the way, there is a buzzer for audio output here, and also over here for connector, for connecting to the motor. And now let's see into the datasheet. This chip is kind SoC, system on chip, exactly. This produced from On Micro Corporation, and for general, this chip is integrate high performance and low power RF transceiver with Bluetooth based band and rich peripheral I/O extension. Also integrate a power management to provide high efficient power management. And let's see into the power management. When we look into power management, consuming power only 4 microampere in deep sleep mode, and with supply voltage range 1 to 3 voltage, built-in back DC to DC. So that reason why this device can really low consuming power, because if we compare with one of the development microcontroller low power like NRF Nordic, that can consuming power more, that is 5 microampere. in a deep sleep mode. So this is one is more or less. And other than that, um, this is also integrated with charge. Uh, so if we look into CPU that use ARM architecture, which is M4F, letter F that mean FPU, it is floating point unit. So this type can processing some floating decimal value. This M4 also include in low power embedded CPU with zero point 0.1 milliampere consuming power. More than that, it combined with Bluetooth Low Energy 5 generation with with 0.5 milliampere consuming power, and that make a great collaboration as a low power circuit. So now this is how look the pin chips. It have a lot of pin I/O. There are 31 digital and analog, and some several communication pin here like I2C, I2S, word communication, SVD, SPI, SPI, almost complete here. Also external crystal here, and there is a feedback charge because we can integrate to battery charging circuit if we needed battery charge. In the board, there is some filter caps and coil here. Go to the feedback over here, and also there are ladder motor plus and minus connecting to a transistor or MOSFET. I'm not really. And for control pin, connect into PWM output from M4, and that will trigger to running the motor. Also many test point to supporting when doing some troubleshoot, and also extend the crystal like we told before here. So yeah, I think that's all our review circuit. For summary, this HS6621CG is a recommendation chips to make some IoT project or like Bluetooth device or smartwatch and other project. Yeah, hope we can give you a reference. Think that's all. Our review circuit, and still healthy, still safety, of course, and always. I'm still waiting for your thumbs up. Yeah, thinks that's enough. See you in the next video. Bye bye.